Today in the workshop we are working with the Arduino Pro Mini, a tiny Arduino with big capabilities. We'll see how the Pro Mini works and how to program it using an FTDI adapter. We'll also build a battery-powered controller for a small robotic arm. It's a small world after all, so welcome to the workshop. Hello and welcome to the workshop. Today we're going to be working with the Arduino Pro Mini. Now, as its name would imply, the Pro Mini is a very tiny Arduino, but it's only tiny in size. As far as capabilities, the Pro Mini has the same capabilities as an Arduino Uno, and that's because it uses the same microcontroller chip that the Uno uses, the ATmega 328. In fact, many Pro Minis have two additional analog to digital converters that the Uno does not have, so in that respect it's even a bit more powerful. Now, there is one thing that the Pro Mini does not have, however. It does not have a USB port, and in order to program it you're going to need a device called an FTDI adapter. I'm going to explain how that works and show you how you hook it up and program the device. One nice thing about the Pro Mini is that it is available in both a 3.3 and a 5 volt model, so you can use the 3.3 volt model for low-powered logic circuits and also for battery-powered designs, and we're going to be building a battery-powered project with our Pro Mini today. So what I'm going to do is show you the Pro Mini, show you the FTDI adapter and how you connect the two together, how you work with them with the Arduino IDE, and then we're going to build our battery-powered project. Now, the project we're going to build today is going to use this device. I don't know if you remember this, it's been quite a while, but this is the Mi-arm robotic arm, and it's a small robot arm that has 4 servo motors onto it. We are going to build a small controller for our Mi-arm using a 3.3 volt Arduino Pro Mini, and it's going to be powered by 4 batteries. And I think it's a very interesting project, especially when you see how you can design with 3.3 volt logic. There's a couple of techniques that I'll be showing you there. So let's start off by taking a look at the Arduino Pro Mini. Now let's take a look at the Arduino Pro Mini. The Arduino Pro Mini was originally designed by SparkFun. The Pro Mini has now been retired from the official Arduino board list, so you can't buy one directly from the Arduino store anymore. However, since the Pro Mini is an open source design, it is still manufactured by several companies and is widely available. The Pro Mini uses the ATmega 328 surface mount chip. There are 2 versions of the Arduino Pro Mini, a 3.3 volt 8 MHz version and a 5 volt 16 MHz version. Because it uses the same processor, the Pro Mini has similar features to the Arduino Uno. It has 2 additional analog inputs because it uses the surface mount version of the chip. One difference between the Pro Mini and the Uno is that it has no USB port. In order to program the Pro Mini, you will need an FTDI adapter. Let's take a look at some of the pins on the Arduino Pro Mini. First, we have the digital input-output pins. Next, we have the analog inputs. There are 8 of them, however, on some Pro Minis, only 6 of them have been brought out to the board. On the side of the Pro Mini is the connector for the FTDI interface. The VCC pin is where you apply either 3.3 or 5 volts to your Pro Mini, depending on which model you have. The raw pin can use unregulated voltage. In this case, the Pro Mini's built-in linear voltage regulator will reduce the voltage to the correct amount. There are also 2 ground pins and 2 reset pins. And there are 2 pins for serial input-output. These can also be used as digital I/O pins 0 and 1. Now, when you purchase a Pro Mini, it usually comes without the headers attached. The headers are included in the package and will need to be soldered on. This actually allows a lot of versatility because you can use different connectors or just connect wires directly to the Pro Mini board. So now let's start working with the Arduino Pro Mini. Now here I have some Pro Minis as well as some FTDI adapters for you to take a look at. Now first we'll start with the Pro Minis. This is a 5-volt Arduino Pro Mini, and this is a 3.3 volt Arduino Pro Mini. As you can see, other than the color, they look quite the same, and so it's very important for you to know which type of Pro Mini that you are going to be getting. Now I've got pins soldered onto these Pro Minis over here. You can see pins here for the FTDI adapter, plus pins I've soldered on the bottom of it in order to plug it into either a socket or into a solderless breadboard, or just solder it directly onto a printed circuit board. And I've done the same with this one over here. This is how they come from the factory. This is actually 3 of them, of the 3.3 volt ones, and as you can see, they don't actually have any pins on them. You need to solder them on. The 5 volt one came in a package with some pins on it. I'm actually kind of amused. You probably can't read that, but it says, "Caution, static sensitive devices not to be handled by unauthorized personnel." Now I'm not sure how you get authorized to handle an Arduino Pro Mini, but I'm just going to take my chances. Now these are 2 FTDI adapters. This one has a jumper on the back for the 3 or the 5 volts, and it's actually already connected as 5 volts. If you wanted to use it for 3.3 volts, you'd have to actually slice a small trace and put a solder bridge over it in order to do that. On this one, they have a jumper over here that you can set for either 3.3 or 5 volts, and that makes it a bit easier. Both of them, as you'll note, have USB connectors, and they use mini USBs, not micro USBs, so you'll want to make sure you have the right cable for that. And the final thing I wanted to show you was this. This is just a little piece of perf board that I soldered up with a couple of female headers and some male headers, and they're just connected pin for pin. And this just allows me to plug a Pro Mini into one of these and experiment with it a little bit easier than I can, especially if I don't want to be using a solderless breadboard. There's no problem with using a solderless breadboard, but the pins can sometimes stretch the contacts on the breadboard. And so there you go, a few Arduino Pro Minis for your amusement. Now let's go and start to actually work with these devices. FTDI adapters are available in several different shapes and configurations. Now, as you are going to be powering the Arduino Pro Mini from the FTDI adapter during programming, they also have a method of selecting the output voltage, and it's important that you set that correctly. Some adapters will have a small switch, others will have a jumper, whereas others may have a trace on the circuit board that you need to create a solder bridge over. Whichever method your adapter uses, make certain that it is selected for the correct voltage for your Arduino Pro Mini. FTDI adapters have several output pins. However, there will be a set dedicated to programming the Pro Mini. The connections are as follows: the DTR, or data terminal ready, the TX, or transmit, RX, or receive, the VCC, which is the power that is being sent to the Pro Mini, the CTS, or clear to send input, and a ground connection. Now, in most cases, the pins on the FTDI adapter will line up with the Pro Mini. However, be aware that some FTDI adapters and some Pro Minis do not have pins that line up. Also be aware that some of them are mirror images of the other ones. It's always best to check your connections. In order to connect an FTDI adapter to a Pro Mini, you need the following connections. The DTR on the FTDI will be connected to DTR on the Pro Mini. The TX, or transmit, on the FTDI will be connected to the RX, or receive, on the Arduino Pro Mini. The RX, or receive, on the FTDI will be connected to the TX, or transmit, on the Pro Mini. VCC will be connected to VCC on the Pro Mini. The clear to send input should be grounded so that it is always clear to send. Most Pro Minis have an additional connection that is grounded for this purpose. And of course the ground should be connected to ground. So now you know how to connect your FTDI adapter to your Arduino Pro Mini. So I've got both of my Arduino Pro Minis, a 3.3 volt one and a 5 volt one. And I've also got my two FTDI adapters that I showed you earlier. Now, if you remember, the two Pro Minis had their pins reversed, and the same was true of the FTDI adapters. Now, had I put a female connector onto the Pro Mini, I could have plugged the FTDI adapter directly into it, but I just decided to use jumper wires, and to make things easier on myself, I used the same color jumper wires for the two Arduinos. Now, you just hook these up according to the diagram that I showed you, matching all of the pins on the Arduino Pro Mini to the FTDI adapter, and you should be fine. Now, remember to set the voltage correctly on your FTDI adapter. This one has now been strapped for 3.3 volts, and this one already has a jumper set on the back for 5 volts. And so what I'm going to do right now is I'm going to run a very simple sketch on both of these and show you how you can use the Arduino IDE to program them. Now remember, the FTDI adapters require a mini USB, not a micro USB or standard USB cable, so you'll need to have a mini USB cable for the two devices. So let's go and take a look at the Arduino IDE and see how we set ourselves up to program both the 3.3 volt and the 5 volt Arduino Pro Mini. Alright, here we are in the Arduino IDE. Now I've connected my 3.3 volt Arduino Pro Mini up to the USB cable, so we'll work with that one first. Now the first thing you need to do is to go into Tools and go into Board and select the correct board. So go down and select Arduino Pro or Pro Mini. Next, you need to select the correct processor and frequency. So mine is an ATmega 328P, 3.3 volt, 8 megahertz. This is important to do, otherwise your timing loops can be off in your program. Notice that some older Pro Minis use the ATmega 168. These really don't exist anymore, but you might have an old one, so you might want to take a look at your board just to make certain that you're using the ATmega 328. Okay, after that you'll need to go and select the port, which should be pretty obvious as it is with any Arduino program. Now, keep in mind that if you're using Windows, you may need to install an additional USB driver for your FTDI device. If you're using Mac or Linux like I'm using, that shouldn't be a problem. Now that you set it up, you can pretty well use the Arduino IDE as you always would. So let's go and open everybody's favorite sketch. And that is, of course, under Basics, the Blink sketch. Now, the Blink sketch is a great sketch to test out new Arduino boards with because it's a very simple sketch and we all know how it works. However, one thing is when you buy a new Pro Mini or pretty well any Arduino board, it already has the Blink sketch loaded on it. So it's really not that exciting to watch the Arduino just do the exact same thing it was doing when you took it out of the box. So what I like to do is I like to modify the Blink sketch. So let's change the delay time and turn the LED on for 4 seconds instead of for the 1 second, and that's turn it off for 2 seconds. And that should be distinctive enough so that when we load that up to the processor and look at the built-in LED, we should be able to see it flashing at a different rate than it was when we first plugged it in, just to make certain that the processor was working. So now that we've done that, let's upload that to the Pro Mini. And it's done uploading. And we'll take a look at the results for that in a moment, but first let's go and disconnect. I'm going to disconnect the Pro Mini right now, and I'm connecting up my other Pro Mini. Now this is the 5 volt one, so again I'm going to need to go into Tools. The board is correct, but the processor is going to need to be changed over here. So now I've changed the processor, and just make sure it saw the port. Yes, it saw the port. Okay, and now let's upload that. And it's done uploading as well. Okay, so now let's go and take a look at both of our Pro Minis. We should see the Blink sketch running. We're just going to be using the onboard LEDs to monitor it, and we should see it staying on for 4 seconds and then going off for 2 seconds. And so here we're back at the breadboard looking at the results of our modified blink sketch. Now I've got the 3.3 volt Pro Mini hooked up right now, and as you can see the LED is staying on for a long time and off for a shorter period of time, which is how we modified our blink sketch. I'm hoping you can see this blue built-in LED. So that does seem to work. Now what we'll do is we'll just disconnect that and we'll move over to the other Pro Mini, the 5 volt version, and it uses a red LED, and as you can see the same effect. It's staying on for longer than the original blink sketch and going off for a shorter period of time. And so that's a very simple demonstration, of course, but it does show you how you can program the Arduino Pro Minis. So now let's go and do something more interesting with our Pro Minis. Now before we move on to construct our MiArm controller, I want to mention one last thing about hooking up the FTDI adapter to the Pro Mini. Now in the experiments you saw me perform, I used a series of jumper wires in order to connect the FTDI to the Pro Mini's FTDI input. But I actually didn't need to do that because in both cases the adapters either lined up correctly with the correct pinouts in the same order, or they were just the opposite, and I could have turned one of them upside down, either the Pro Mini or the FTDI adapter, and they would have lined up. Of course, they both use male pins, so I would have needed some sort of a female-to-female connector. And an easy way of doing that in this case is to use something like this, just a solderless breadboard, and plug your Pro Mini into one side and the adapter in the other side. Now again, you have to be absolutely certain that the pins are lining up correctly, so use the diagram that I showed you earlier to verify that, and if indeed that works, then this is a far easier way than using jumpers, so I just thought I'd throw that in for you. Now on to our robot arm controller. Now the controller itself is very simple. In fact, you can probably imagine how it works. I've got 4 potentiometers controlling 4 servo motors, so we simply use the pots to control an analog voltage going into 4 of the analog inputs, and then we drive the servo motors with 4 of the digital outputs. There's nothing special about that. What I really wanted to illustrate with this circuit is not so much how to control a robot arm, but instead how to use a 6 volt power supply with the 3.3 volt Pro Mini. Now the Pro Mini, as you recall, has a raw input, and that's where you feed voltages that aren't regulated. So you can feed the 6 volts into the Pro Mini's raw input and use that to control the Pro Mini, because the Pro Mini has a built-in linear voltage regulator, and the 6 volt is also the correct voltage for driving the servo motor, and indeed that's what we're going to do. But what's interesting is that if you look at the schematic for the Arduino Pro Mini, you will come to realize that the VCC pin, the pin you would normally connect 3.3 volts to, is now an output in this mode. So what I've done in this circuit is I've connected my input voltage up to the raw pin, and I'm using that 3.3 volt output as a reference voltage for the potentiometers, because I can't use the 6 volts, because at the top end the pots would be giving up 6 volts, and that would be very dangerous for the Arduino Pro Mini to feed into it. Plus it wouldn't work anyway, because once it got beyond 3.3 volts it would go beyond the limits of the analog to digital converter. So this is really the technique I wanted to illustrate with this circuit. So let's take a look at the hookup diagram right now, and then I'll show you the sketch, and then after that you'll see just how terrible I am at actually controlling a MiArm. So here's how we're going to hook up our simple robot arm controller. We'll start with a 3.3 volt Arduino Pro Mini. Next we'll add some potentiometers. I've used slide pots because I think they're easier to work with, but you could also use rotary pots. Any value of 10K or higher linear taper will work. We have one that we'll use for the claw control, one for the right motor, another one for the left motor, and one for the base. I also added 2 capacitors to keep the noise down on the power supply line. An electrolytic capacitor, I used 100 microfarads, but any value should suffice. And a ceramic capacitor, I used 100 nanofarads, but again the value here is not critical. You'll need a 6 volt power supply, you can use batteries if you wish, and a connector to connect to the 4 servo motors. We'll start by wiring the positive side of the power supply or battery to the raw input on the Pro Mini. We'll also take the 6-volt positive supply and wire it to the positive terminal for all of the servo motors. Next, we'll take the negative from the power supply and connect it to the ground on the Arduino Pro Mini. And we will also connect this to the ground side on the servo motor connector. Now we'll connect our capacitors across the power supply line. First, the electrolytic capacitor. Make certain that you observe the correct polarity. After that, we'll connect the ceramic capacitor. It is not polarity sensitive. Next, we'll take our ground side or negative side and connect it to one side of the potentiometers. The other side of the potentiometers will be connected together and connected to the VCC terminal on the Pro Mini. In this application, VCC is actually an output that will provide 3.3 volts as a reference voltage for the pots. We then take the wiper of the base pot and connect it to analog pin A0. The wiper of the left pot goes to analog pin A1. We connect the wiper from the right pot to analog input A2 and the wiper from the claw potentiometer to analog input A3. Then we take the I/O pin number 9 and connect it to the control pin on the base servo motor. Pin 6 goes to the control pin on the left servo, pin 5 to the control pin on the right servo, and finally pin 3 to the control pin on the claw servo motor. And this completes our wiring. Now that we've hooked up our robot arm controller, let's take a look at the sketch that we'll need to use to load onto the Pro Mini in order to make it work. Now remember to set your Arduino IDE up so that you are using a 3.3 volt Arduino Pro Mini. Go into Tools and under Board, under Processor, make sure you've selected ATmega 328P 3.3 volt at 8 megahertz. Now let's look at the sketch. We start off by including the servo library, which is a built-in library so you don't need to add anything to your Arduino IDE. Then we'll create 4 different servo objects to represent the 4 servo motors, and we're going to call them base, left, right, and claw. We'll also define some integers for the analog inputs that we're using from the potentiometers. We have base pin, left pin, right pin, and claw pin, and they're defined with their appropriate analog input pins. Then we'll define the values that we're going to extract from these potentiometers. Base value, left value, right value, and claw value, and we initialize all of these with a value of 0. In the setup, all that we do is attach the servo objects to the output pins we've chosen. So the base is attached to pin 9, the left to pin 6, the right to pin 5, and the claw is attached to pin 3. Now to the loop. What we need to do is read the potentiometer values and convert them to a value that we can use for the servos, which will be a value of 0 to 180. Remember, the potentiometer values are going to come back as a value of 0 to 1023 because of the 10-bit analog to digital converter in the Arduino Pro Mini. We can do this all with one map statement. So we will map the value of an analog read of the base pin. The analog read will give us a value of 0 to 1023, and we are using the map command to map that from 0 to 180. And we repeat this for the left, right, and claw pins as well. And then we simply write these to the servo. And so these are our servo objects. So we write to the base servo objects the base value we just determined, to the left value, right, the right value, and the claw value. And then we add a short delay because we don't want to keep hammering our servos. This is going to be very bad for them. However, the delay may also make the device a bit unresponsive, so you can experiment with this value if you wish. And that's really all there is to the sketch. So now let's load it onto our Pro Mini and watch it in action. And so here's our controller hooked up on a solderless breadboard. You can see the Arduino Pro Mini, the 3.3 volt one over here. You can see my power supply is actually a 6-volt lantern battery, which of course is a bit of an overkill. I could have used 4 AA cells and that would have worked very well. I could also have used my bench power supply, of course. Here are the capacitors and the slide pots that I'll be using to control the Mi arm, and I say that rather loosely because, as you're about to see, I'm really bad at controlling Mi arms. And naturally, here is the Mi arm itself with the 4 servo motors on it. There's one down at the base, the left motor, the right motor back over here, and the claw motor which operates the claw. So let's go and take a look at my terrible Mi arm control techniques and demonstrate our Arduino Pro Mini robot arm controller. Okay, we're controlling our Mi arm right now with this is the base motor over here. Let's control the claw over here, the left motor, and the right motor. And so it does work. I'm not very good at controlling Mi arms, as you can tell. But we have built a controller for our Mi arm using the Arduino Pro Mini 3.3 volt. Alright, that wraps up our look at the Arduino Pro Mini. I hope you've enjoyed the video and that it's given you some ideas for using the Arduino Pro Mini in some of your own projects. Now, if you'd like some more information about the Pro Mini, or if you'd like the sketch that I used for the Mi arm controller, you'll find that on the dronebotworkshop.com website in the associated article to this video, and there's a link to that right below the video. Now, while you're on the website, please join up with the newsletter if you haven't already. The newsletter is free. It's not a spam letter by any means. It's certainly not a method of trying to sell you something. It's my way of letting you know what happens in the workshop, and also to solicit your opinions about what content you would like me to make. In fact, right now, the only way that I'm taking suggestions for content are through the survey that you will find a link to in the newsletter. It's at the bottom of every newsletter, as well as in the welcoming letter you get when you sign up. So if you'd like to suggest content, please go ahead and fill out the survey and let me know what it is you would like me to create for you. As well, if you haven't subscribed to the YouTube channel, please do that. You'll find the subscribe button right below this video, as well as a little robot symbol in the corner, and you can click on him and he'll subscribe you. So until next time we meet, please take care of yourselves, and I hope to see you very soon again here in the DroneBot Workshop. Goodbye for now.